Project 2.1, the R2R Digital to Analog Converter, or R2R DAC. The R2R DAC is a simple and effective method of converting digital signals into analog voltages through the use of a R2R resistor ladder along with a voltage follower op-amp. Here we're using the LM741. Now let's take a look at how this circuit works. This is a simple 4-bit R2R resistor network. As you can see from this circuit, these two resistors are connected in parallel, meaning that the total resistance of this part of the circuit would be R, shown right here. Now these two R resistors are now connected in series, meaning that they add up to another 2R. Theoretically, this process could be repeated infinite many times as long as there are enough R's and 2R's arranged in this order. This is the perfect example of the Thevenin's theorem, which states that any linear circuit containing several voltages and resistance can be replaced by just one singular voltage in series with a single resistance connected across a load. Additionally, we can also find the voltage level across any junction point inside the circuit through the use of a principle called superposition. Now, in order to show this, we have to turn let's assume that all of the switches are off, except for the first one, which is D0. Now, in this case, since all of the other switches are off, the rest of the circuit is simply inactive, meaning that this circuit is now a series circuit consisting of two different 2R resistors connected in series. Now, since these two 2Rs are now connected in series, this means that the middle point over here would simply be the given voltage coming from the switch to the ground divided by 2. Now, this same thing could be applied to every single one of the other points, which would simply be the previous junction point's voltage divided by 2 again, as shown before in this Thevenin's theorem. This would mean that in this case, this junction point over here, which is the closest to the V out, would have 1/16 of the given voltage, given that all the other switches will be turned off and only D3 would be on. The next major part in the circuit would be the voltage follower, which in this case is the operational amplifier LM741. This voltage follower plays a vital role as a buffer in this circuit. It stabilizes the analog output by providing high input impedance, which prevents the R2R resistor network from being affected by loading. At the same time, its low output impedance allows us to drive other components without distorting the signal. Essentially, the voltage follower ensures that the DAC's analog output remains accurate and stable, and unaffected by any variations in the next stages of the circuit, which would be very useful if you want to connect the circuit into something else. That's it for the R2R DAC. Thank you very much for listening.